Atomic orbitals and quantum numbers show up in questions about electron configurations, periodic trends, and bonding on the MCAT. The key is knowing what each quantum number represents: energy, shape, orientation, and spin, and how those numbers define the behavior of electrons and atoms. Once you see the logic, it's way easier than just memorizing. Let's break it down. Atomic orbitals. An orbital is a region around the nucleus where an electron is most likely to be found. Each orbital can hold up to 2 electrons, but only if they have opposite spins. That's the Pauli exclusion principle. Principal quantum number n. The first quantum number is n, the principal quantum number. It tells you the energy level and distance from the nucleus. Values are positive integers, 1, 2, 3, and so on. Higher n means electrons are farther from the nucleus and at higher energy levels. Angular momentum quantum number, L. Next is L, the angular momentum quantum number. It determines the shape of the orbital. For each value of n, L can range from 0 up to n-1. Each value of L corresponds to a specific subshell. L equals 0. S orbitals. Spherical shape, L equals 1. P orbitals. Dumbbell-shaped, L equals 2. D orbitals. More complex shapes, L equals 3. F orbitals. Even more complex shapes. Magnetic quantum number, m sub L. The third quantum number is m sub L, the magnetic quantum number, which describes the orientation of an orbital in space. It can have values ranging from negative L to positive L. For example, if L equals 1 for p orbitals, then m sub L can be negative 1, 0, or positive 1, giving the 3 possible orientations of p orbitals. Spin quantum number, m sub S. Finally, the spin quantum number, m sub S, describes electron spin. It's either plus 1/2, spin up, or minus 1/2, spin down. This is why each orbital holds exactly 2 electrons, 1 up, 1 down. Orbital shapes. To recap orbital shapes, s orbitals are spherical, p orbitals are dumbbell-shaped, d orbitals have 5 orientations with clover-like patterns, and f orbitals are even more complex with 7 orientations. These shapes help explain bonding and molecular geometry later on. Electron configuration. Putting it all together, electron configuration tells us how electrons fill orbitals. The rules. Aufbau principle, fill from lowest to highest energy orbitals. Hand's rule, fill orbitals singly before pairing. Pauli exclusion principle, no 2 electrons in an atom share the same 4 quantum numbers. For example, oxygen's configuration is 1s2, 2s2, 2p4. The 4 electrons in the 2p subshell fill 1 electron in each orbital first, then pair up. So here's the takeaway. Every electron in an atom is described by 4 quantum numbers n, L, m sub L, and m sub S. Together, they define the energy, shape, orientation, and spin of that electron. Mastering these rules makes electron configurations, bonding, and periodic trends fall into place on the MCAT. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.